Gravity. What is it? How does it work? And can it be modified? Hey everybody, I'm really excited to bring you this video today. After a few years of trying to get this together, I've eventually met up with the entire team of Project Greenglow. Back in 1990s, BAE commissioned Ron Evans to lead a team to look at everything in association with modifying gravity. So today, for possibly the first time, I've managed to get Ron Evans, Rob Chambers, and George Safang, all members of BAE Project Greenglow, together to talk about what is gravity and how successful was Project Greenglow in modifying gravity. So I'm very honoured to bring this to you, viewers, and I'm even wearing a new sweater to celebrate it. Having these eminent scientists and engineers together was a challenge. I had to come up with a series of questions. So I thought, why don't we talk about the history of gravity? What is gravity? What do we know about it? And possibly, how do we modify it? So we started in 1666. And why not? The young Isaac Newton was in pandemic lockdown. There was some bug going around Britain called the plague or the Black Death. So he buggered off to his parents' house in Lincolnshire and used that forced isolation, as we have recently done, to think about stuff. The story goes that in late summer, when the apples were ripe on his parents' orchard, he sat under a tree and saw, blink, a stalk let go and an apple fall to the ground. Why did it fall? What was the nature of the unknown force pulling it down? Click. But hang on, as with all great science inventions, the young Newton actually wasn't alone. He must have been looking at his Twitter and Instagram account, because over in Italy, his mate Galileo was also asking the same questions. And what he did was go up the Leaning Tower of Pisa and drop a feather and a weight to see if they dropped at the same time, and they do. Let the games begin. The race was on to fully explain the mathematics behind falling objects, things in motion, acceleration, and force. Amazingly, today, 2025, not in this room, but today, we can still use Isaac Newton's mathematical equations to send a rocket to the moon. Newton's measurements of gravity, acceleration, and motion were so accurate, we can send today a satellite round Venus on its way to a moon of Jupiter and get it right. It still works. But despite the brilliance of the arithmetic, Newton really didn't explain why and how. That had to wait for 249 years. You can figure that out. 1666, 240. Yeah, you can figure out my clever storytelling device, of course, 1915. Albert Einstein's general relativity. Now, it's interesting. We think general relativity is about time. It is, because time and gravity are linked. A new word came into the English language. In fact, two words now joined together: space and time. Space-time. We really can't define a really accurate position in space without calling it space-time. Neil deGrasse Tyson nailed it. If I said, I'll see you tomorrow at noon, you will ask, where? Or let's meet up at the bar. You'll ask, when? Space and time are linked. But Einstein took that concept one step further. In fact, 3 steps further. He defined this triangle. At the top is space-time, at the bottom is mass, and at the other point of the triangle is an effect called gravity. As an amazing theory, as a thought experiment, Albert Einstein said, mass distorts space-time. Distorted space-time affects gravity. Gravity isn't a force. Gravity is a side effect of mass distorting space-time. Suddenly we had a theory, an idea of why and how an apple falls under gravity. But is it true? We need an experiment. But first of all, we have to stop. Hang on. The three best physics experiments ever carried out by humans, in my humble opinion, are number one, that mass bends space-time and affects gravity. Number two, something done by the phone company. Yes, Bell Labs discovered the cosmic microwave background, the most important moment in the early universe where disassociated matter in the form of plasma all coalesced into stable atoms and threw away blunk light. Absolutely stunning and brilliant, excuse the pun. And number three was done in Cambridge, England, by a man from New Zealand, Ernest Rutherford, where he shot alpha particles through a sheet of solid gold. They passed right through. 99.999% of all atoms is empty space. The chances of an alpha particle hitting the proton, the middle of an atom, he said was like shooting a fly in a cathedral. There is no stuff. We're just electromagnetic bonds. And we'll come on to that because that redefines how gravity might work. So that was my fiendish plan, to talk about the history of gravity going back to 1666 and to bring us up to date with subatomic spin modification that companies like Vulcan Space are currently working on, and it might hold the clue to making your flying car. Let's see what the guys have to say. So people, join me on this really privileged discussion. Imagine going down to your local bar or coffee shop with Ron, Rob, and George, the three people employed to modify gravity in the UK by a defence contractor who know how and why it works. YouTube is really the new window to the world. What a privilege to sit down with these people and for me to share this with you. I'm sure you're going to enjoy what these three chaps are about to say. If you like this kind of thing, give it a thumbs up and please subscribe because it encourages YouTube to share this window on the world for you.
Hey, everybody, this is unbelievable honor to have George, Rob, and Ron, the men of gravity, the men of great gravity, all together with Humble Me. And today we're going to talk about the history of what they did, but the history of gravity generally. And I think we should actually start in 1666. Why not? There's a plague going on in Britain, and the young Isaac Newton decides to bugger off to Lincolnshire to his parents' farm to escape London or Cambridge, wherever he was living. And I'm not sure if it really happened, but supposedly he saw an apple fall from a tree. How, gentlemen, did the Newtonian idea of what he defined in his laws of motion and gravity, how do you think it affected humans and society? You know, what does physics do?
It took an enormously long time. Initially, people thought it was magic.
Right.
So they had to be persuaded that Newton's ideas were right. So he needed an experiment. And he did. His experiment was the apple on the tree and the moon falling. That was the experiment. Whenever we do gravity, if we've got a new model, we must do an experiment.
So obviously apples fell from trees before he defined what it might be and gave it a name and also some amazing laws. So, I mean, how do you think a farmer who knew that apples fell from the tree a few months before he might have learned about the word gravity and Isaac Newton. How do you think it changed the world?
Well, it took time, but don't forget Newton, while he was at Cambridge, was immersed with an enormous number, well, a lot of people, not just one or two, three, four, five people that were eventually involved with the Royal Society. And they were interested in that area. They hadn't got a model for it, but they were interested in it. And so he'd looked at the work of Kepler. Well, he had those three laws. He knew he had to follow up with them, and he showed that he could.
Yeah, because Kepler's laws were empirical, so there was no reasoning, there was no logic to it. He was describing what he saw, and it was Newton then who was able to put equations to it and to explain why the laws worked the way they did.
Yeah.
Same with Galileo, who legendarily dropped objects of different weights, different sizes, and they fell at the same rate. Again, he didn't really have a model to explain why that happened, but Newton was able to give a grounding to everything.
But gentlemen, we can today still fly a spacecraft orbiting a planet, slingshotting to a far distant thing in our solar system, if not beyond, using a law of Isaac Newton. I mean, does it still work?
Yes.
Yes.
Go on, Rob.
No, I was going to say it's what they call good enough for government work. It's accurate enough, as long as you don't go to extreme environments like Mercury, for example, because this is where it falls down, is to describe the orbit of Mercury, which is very close to the sun. So gravity is more intense. You might say the curvature of space-time is bigger, and so it becomes less and less accurate, and that's why it led to people like Einstein coming up with something which was more accurate in those extreme environments.
You take the words out of my mouth, Mr. Chambers, because that's the next thing I was going to mention. The best story, apart from gravity, in physics is the hunt for planet Vulcan. I mean, it's just brilliant, that story. And Rob and I both live in France, and the chief French astronomer, Levernier, I can't say his name, managed to use Newtonian physics to predict the position of Neptune by looking at how Uranus was perturbed by obviously another planet. And when he then turned his attention to little Mercury, it was obvious that there was something pulling Mercury into a perturbed orbit, which he is thought, using Isaac's great physics and mathematics, that there must be a planet called Vulcan between the orbit of Mercury and the sun. But who would like to tell the story of why that is wrong?
Very, very complicated. Who's going to
I'll let someone else take it.
Oh, I'm such a TV person. I mean, let's just mention, I'll give you a name check. Who's going to say what Arthur Eddington did?
Well, he supported Einstein, of course.
Right. And it all worked out. I mean, when Arthur saw that in a total eclipse, a star's position was moved because he could see it behind the now eclipsed sun, it changed everything, because Albert Einstein said that mass, correct me when I'm going wrong, mass distorts space-time, and this new word, space-time, two words joined together. And when Arthur looked at the position of a star, he realized that space-time was distorted due to mass, and the star was in the other position, and that accounted for Mercury's perturbed orbit. What of that have I got wrong?
I don't think you've got anything wrong, but where does it take us? It's the question I ask.
Right. All right. So we've got these two. So those are the two big things of of gravity, in my opinion. I mean, you've got the apple, and then you've got planet Vulcan not being right, and Albert Einstein. But I'm going to jump right into a hornet's nest with you guys, and suggest that there's another part of physics which might I'm very interested in what you have to say about this. Might redefine gravity, and that's not a gravity person, and that's Ernest Rutherford. When Ernest Rutherford did his gold foil experiment in alpha particles, he described a very dense solid metal gold. The subatomic particles were so spaced out that hitting a proton with an alpha particle would be the equivalent of hitting a fly in a cathedral. So now we have atoms not being solid stuff, not being plum puddings, not being meatballs anymore, but they're just pure electromagnetic forces. Do you think, and was it useful? Do you think that now that we've redefined the actual basis of matter of atoms, does that redefine did that did that definition of atomic matter redefine how you look at gravity and how gravity works? I'm so intrigued to hear what you have to say.
Who wants to volunteer?
So atoms are electromagnetic forces. There's no solid bit. How does gravity work once that's been established?
Well, they're very small, so gravity plays a very, very small part at the level of the atom
Right.
or the nucleus. So there is a tiny amount of mass there, but it's very, very difficult to do any kind of gravitational measurements at that scale. Personally, at university, we used to try to repeat the Cavendish experiment, where you have lead balls and you time it. It swings to and fro for hours, and you have to measure the deflections and so on. And if you're lucky, you get out by a factor of 10. If you're lucky to find the value of big G, which is the gravitational constant. It's very, very difficult even to measure these things even at a macroscopic scale. So it's been very difficult to think about gravity or to measure it to make any kind of calculations at the atomic level. So you have to look at large quantities of matter when you want to do experiments with gravity.
Right.
So, for example, there's Bob Forward. I don't know if you've heard of Bob Forward. Ron knew him, who was a physicist who, in the 60s and later in the early 90s, did a number of papers about making general relativity approachable for engineers, so that you could put it in a way that engineers could find useful. And in some of those involved, for example, replacing electric current with a mass current. So you could apply an analog of the laws of electrodynamics to, yeah, exactly,
Right.
to matter. So instead of having electric current, you could replace that with a mass current, and you would end up with a set of equations that are quite similar, not exactly similar. It's an analog, not an exact copy.
Right.
And so by using large quantities of matter, you could potentially create effects, but it would be a very, very large amount of matter. So the numbers are astronomical if you want to create anything which is measurable. So you could create, in theory, your own gravity field or anti-gravity field, but it's not practical at the moment anyway. It's not practical. But
Hang on a minute. What I don't understand is, okay, if we believe the theories of Isaac Newton and that an enormous amount of mass, something like our sun, which is massive, distorts space-time, and it produces a gravity well, and everything's falling into it, and gravity is no longer a force; it's a side effect of distorted space-time. How on earth could you ever imagine anything that could modify that apart from more mass? And you can't have something as massive as that in an airplane. I mean, it's just, you know, how did you gentlemen even begin to think that gravity could be messed around with apart from by mass?
Because we're idiots.
Yes.
No, no. I think what we thought was, hang on, we're not going to make a black hole. So
Right.
we're not going to be able to affect gravity that way. But there's something else happening telling us that there's an effect. And this is where people like Lathwaite and Sandy Kidd arrived on the scene. And they said, well, what about a gyroscope? There's a funny force there. And certainly we had a look at it. In fact, we tested a device at our site, but we didn't find an effect. But we looked.
Yes.
Okay, all right, all right. Really, I'm going to skip my questions now because you guys are great. So gravity's for mere mortals, us, you guys, affecting gravity is bollocks. I mean, how on earth did you, Ron, or if it was you, how did you sell the idea, and why were British BAE in any way interested or even going to fund a project that would look at altering something which is unalterable, or
Well,
was it?
for a start, the money that was funded was fairly small.
Okay.
Were never large, and there were a few senior people at BAE where we worked who were interested.
Hmm.
In fact, the technical director was very interested because he went to Salford and gave a lecture on how gravity might, coming to use Rob's words, be an analogue of electromagnetism and what
Ah,
could be done with it. And his conclusion was, at the end of it, no, there's nothing. But it didn't stop him looking. Now, I want to just move back a bit. I've got a
yes.
book here. Where is it? I want to mention a book. It's there. We had support quite often from a man called John Allen. John
Okay.
Allen was at Kingston, where they made the Hawk and the Harrier.
Yeah.
And he wrote this book in the 70s. And in it, he wrote a chapter about anti-gravity. Was it Sidney Cam that told him to take it out, George?
Probably. Yes.
He had to take it out. But he's left a mark inside here in his book about anti-gravity. So we got somebody who was, I think he was the head of research at Kingston. That's,
Okay.
it's quite somebody important. And he was in, if you could only make an effect somehow, might be small, then it was worth looking for. So
But what is anti-gravity? I mean, mass distorts space-time. How on earth, and it's a dip. How on earth could you have a hill?
why not?
Negative mass.
Right.
Yes, negative mass.
Yeah.
Right.
This is another thing that Bob Forward was talking about in the 90s. He came up with a paper to demonstrate how if you had some negative mass, you could propel something indefinitely with positive mass indefinitely.
Right.
So finding it is the problem.
Right. Right.
Yes, not only finding it, capturing it and keeping
Yeah.
it.
Yes.
But we've just recently had CERN manage to make antimatter, a tiny bit of a gram of it, which is brilliant that they actually did it. And they put it in a vertical column and they dropped it.
Yes,
And did it go up or did it go down?
it went down.
It went down, right.
So antimatter is not anti-mass.
Right. And that kind of made sense. So at the same time that BAE or BAE Systems, what BAE at the time when you were working there, were there other defense contractors you think looking at gravity modification, if that's a good word?
Or if you look on the Wikipedia, you will find in the 60s and early 70s, a lot of American aerospace companies were working in the area. A lot of them.
Yeah, it sort of went very quiet, I think, didn't it? There was a period in the 50s and early 60s, as you say, that a lot of the companies were talking in public that they were researching it and they hoped for a breakthrough very soon. And that kind of went quiet afterwards. And some people say, oh, that's because they discovered something and they wanted to keep it secret. After that, it could equally mean there was nothing there and they gave up because it wasn't worth their time.
Right.
You've got to look. You've got to look.
Yes, yeah. You don't know if you never look, you don't know. So, yeah.
And why do you think, as a human race, after World War II, when a blackboard equation got turned into an actual weapon with the Trinity Project, do you think that the military wanted another physics trick, another physics possibility? Is that, do you think that was why gravity research was important? Do you think after World War II there was a lot, that was the kind of thing that they were looking for, and that's why you guys were doing it?
I don't know. Mathematicians and physicists just want to do it. They don't think about weapons. Weapons are thought of by the politicians, whether they want something. I don't know. I mean, obviously, physicists can be sucked into something, a weapon. You get paid for a start working on it. We all need some money.
But it's fascinating.
Generally, I think most of us who are mathematicians and scientists are just interested in the physics of it.
Right. Right. Yeah.
If we want to go into space, gravity is essential. We must understand it. We're not going to go anywhere with fuel.
No, I mean, burnable, usable propellants are not going to work, are they? No, we definitely have to, to travel. So what? I'm such a media person. What's the when you studied gravity and you looked at shielding and modifying it, and obviously the word anti-gravity comes into it. What did you find is the connection of gravity with time? I mean, you can't affect gravity without affecting space-time. Is that roughly right?
Yeah. I mean,
So what kind of effects did you find, and what was your research into time modification as well as into gravity shielding or modification?
I'm a mathematician. I'm not an experimentalist,
Right.
but there was something called the Einstein gravitational redshift, which also affects time.
But did in Greenglow specifically, were there actual practical experiments done, or was it more you guys gathering together all the research that you could find for to publish a paper?
Well, we didn't publish papers. The only person who
Right.
published papers, it would be senior people at BAE.
Right.
Us ERCs, or whatever we call ourselves, generally weren't allowed to publish.
Right. Right.
Yeah. But I mean, Greenlow was more about funding academia, wasn't it? Really.
Thank you, Rob. Thank you. Yes.
So that you'll find papers where there is references to thank you to Greenlow for the funding, that kind of thing, or Ron Evans directly. You'll see sometimes named in the sort of acknowledgements of papers. So my understanding was it was mainly about funding individual, sometimes individual researchers in British universities. On kind of vaguely gravity-related things. Sometimes I know it was the Casimir effect as well. Was that Birmingham?
Yes, Birmingham. Yes.
Right.
So things that were related to not necessarily specifically gravity, but which might offer a means of propulsion. So yeah. And I mean, for example, we had that's how I came to meet Dr. Pokletnov, who was invited because Sheffield were being funded to try to replicate his spinning disk experiment. So that's how we came to meet initially. And so unfortunately that wasn't successful, but I think Dr. Pokletnov would also agree that the people doing the experiment at Sheffield also would agree that it wasn't an exact replication. They were limited by funding. So they tried, but it had no result. As far as I know.
Thank you for that, Rob. Yeah, very good.
Although he did get possibly good results himself. but it was hard to reproduce.
Yes, yeah.
That's what
I know there was a team in the US who were funded to replicate it as well, but they had physical problems with their disc because it was so large. When you make them that sort of a foot across, when you make them that big, they are very fragile when you try to spin them very quickly. And this is an ongoing issue. If you have a large amount of mass and you want to spin it to create a mass current, as I was saying earlier, physically it's very difficult because it's likely to fly apart. So it's quite dangerous for the experimenter as well. So you'll find some discussion of things like mercury plasmas, because obviously mercury is quite heavy, and you can make it into a plasma and spin that around instead. And so then you get into, if you search things like mercury plasma on the internet, you'll find talk about the TR3B and things like this. So these sort of speculative or imaginary, who knows, aircraft that allegedly use something like a spinning plasma in order to fly, or at least to negate the effects of gravity. And then quite often you'll find that there's some device that negates gravity, but then you have to propel it conventionally or in some other way.
And do you think those systems exist? I mean, is there would you call them like lift augmentation?
I suppose, because I think the even with Pokletnov, his experiment he'd say, well, I could maybe reduce it by 2%, the weight by 2%, but that's a big saving. If you're trying to launch a rocket or something, 2% is a lot. So anything is good. any possible gain is good. Yeah.
So Rob, you're wonderful. You're again taking the words out of my mouth. I mean, the one thing that keeps coming up in gravity research that I've seen is in different aspects, both physical and in subatomic, is the word spin. So, gentlemen, what's the relationship of things spinning, big stuff or subatomic stuff, to how gravity works? Big question. Is there do you think it's a clue? Is things spinning in motion? Is it important to gravity research? Yeah.
Probably. I don't know.
Right. George?
Well, it's superficial, really, isn't it? Because spinning things have centripetal force, which sort of like a gravity force. So people sort of think, well, if you can affect spin, perhaps you can affect gravity as well. But we haven't seen it yet.
Yeah, Ron, you said that part of Project Greenglow, you definitely looked at Frederick Alphafon's work, and he's very interested in subatomic spin, and today that work continues with the
yes,
with Vulcan space.
I didn't know about that. That was interesting. Yeah.
Yeah, both Rob and Ron and myself, George, have a mutual friend called Tim Ventura, and Tim is very connected in the American physics and space community, and he knows this company called Vulcan Space, who have taken Frederick Alphonson's experiments, and in fact his machine, which he sadly Frederick failed to make work due to funding and various other things. And they're now really are getting small but significant effects with different materials. What all of us here, all us four would call aluminium, is a particularly good, interesting material. So talk to me more about what you think could be working with spin. And should we be looking at subatomic spin? Could that work?
It's not an area that I've explored very far on spin. I mean, I'm very interested in photons, and they've got spin.
Right. Do they? Right. So, at the time that when you were all working, obviously you've continued to work and you continue to follow this field. what would you think would be the most profitable and best way to either modify or shield mass from gravity? And were you successful? Is there a successful program, do you think?
Not as far as I know, but then of course, if it's funded by the United States, it would be military, wouldn't it? And we wouldn't know.
True.
But Britain and France, of course, are leading countries who have always done excellent physics. I've always thought very much that the big physics experiments and the big breakthroughs are probably going to actually come from European science. The Americans might have the funding to produce an experiment or the materials that might be hard to fund in Britain. But I think what you gentlemen did and the kind of people you worked with in the greater Greenglow investigation, people in Britain must have come up with very good ideas. Who did you come across that you thought was who had a good approach, who are British?
Good question. I mean, we are ordinary engineers. We are not leading physicists in the gravity field. So you've got places not far from here where I'm just trying to think what it's called. It's near Liverpool. What's that place? I think really what I want to say is if you're going to follow Albert Einstein's general relativity, you're not going to go anywhere. I'm sorry to say that, and I can say it because I'm a nobody. If I was a scientist still working, I would keep my mouth shut because you're not allowed to say that. Albert Einstein's work might be right, but I don't see it's going to take us anywhere.
Right.
With working on gravity.
Yeah.
We're not going to build a black hole and therefore alter gravity. At the moment, we don't know how to find antimass. We don't know how to do it. We know what its effect will be, and we can do all the modeling for it, but we don't know where to find it. There are people working on things like that, and I think it was Oxford that have been doing it.
Yeah.
Can you remember, Rob, who it is?
At Oxford, did you say?
Yeah, I think it's Oxford, aren't they? Haven't they just discovered that they could do something and it created antimatter and antimass rather?
Antimass, right.
Yeah.
I haven't seen that. No, I'll have to look for that.
I will.
But the big point that Ron's making, which is very interesting, is that Einstein's idea of mass affecting space-time is a good model, and we can do an experiment. We can see that space-time is modified by mass, but it's not. Is what you're saying, Ron? Is that it's not that theory is not going to make anything that can modify gravity in a practical way?
I'm an ignoramus I've been through Einstein's equations.
Right.
I can work through them. I don't have a feel for them, which is what you need as a scientist. But I can't see myself where it's going to help us in terms of propulsion or anything like that. I just can't see it.
Yeah. Yeah, I think that the problem with general relativity is that it's essentially a classical theory. It isn't the complete answer, and I think everyone in the physics domain realizes that because it clashes with quantum mechanics. So clearly there's something else going on. There have been some. Famously, you probably heard of Jack Sarfati. He is more from notoriety than anything else, but. But he's proposed something looking at general relativity within materials, because usually general relativity, I think for simplicity, we look at it in a vacuum. and so you have all the vacuum permeability and permittivity and so on. And I think what he's kind of proposing is that if you had a material or a metamaterial, if you like, with the right qualities, with the right permittivity, permeability, and so on, that it perhaps would enable you to somehow modify space-time in such a way that it would effectively reduce your apparent mass. But again, it's highly speculative, and it's only, again, it assumes a metamaterial which doesn't exist yet, if ever. Because you may have heard of metamaterials recently or a few years ago where they were able to create a negative refractive index.
Yeah.
For certain frequencies. So if you could do something like that, but for gravity instead of electromagnetism, then potentially you could achieve something. And I think this is also the interest in looking for an analog between gravity and electromagnetism, because mass is essentially condensed energy. So if you could concentrate enough energy into a small enough space, you maybe could have the similar effect of having a very, very large mass. Potentially, there's been some talk recently. I don't know if you've heard of Salvatore Pais, Pais, who one of the things he talked about was the what's called the Schwinger limit, where you have enough energy in a small enough space that you, potentially rip space-time. You create a hole, or so you could almost think of it as a black hole being created with energy instead of mass. But again, it's not something which is practical today, but it's potentially it's a theoretical speculation.
Jack Sarfati is very keen to make the distinction between what he calls the big world of big atoms and the inner world of subatomic or the quantum world. So do you think that there's more chance to be able to affect how matter is affected by gravity in the subatomic world, in the inner space, in the quantum world?
Well, Ron, do you want to?
No, I'm leaving it to you.
Well, no, what I was saying was goes back a bit to what you were saying earlier about spin. That, of course, and I think this was mentioned in an earlier interview with the people from Falcon Space, is that at the subatomic level, spin isn't actually spin; it's angular momentum. So they're not actually spinning, because certainly with a point particle, you can't say that it spins. But it has a quality which has the same dimensions as spin. And so an interesting thing is that the materials that they've been looking at for the Alciphon experiment, one of them is bismuth. And bismuth has a long history in gravity studies, going back to the 1920s with Charles Brush, because around the time when general relativity was first introduced, there were a lot of other competing ideas about gravity. And Charles Brush was a wealthy, sort of inventing was his hobby, or science was his hobby, but he was a very wealthy industrialist. And so he was self-funded. And so he did a number of experiments with pendulums of different materials. And he found that bismuth was one of those materials which didn't seem to swing at the same rate as other materials. So it suggested there was something strange going on. And in the 1960s, Henry Wallace, he's had a couple of patents in the 60s and 70s, again suggesting the use of bismuth for gravity reduction potentially. And I think his idea was that maybe it was something to do with the spin, because bismuth has a very large half integer spin. I think it's 9.5, 7.5, 9.5, and maybe having a large half integer spin has something to do with gravity. Or also bismuth is also very diamagnetic, so it has a tendency to push out magnetic fields. And so maybe there is a relationship between diamagnetism and gravity, maybe that you'll be able to push out gravity to some extent, but again, this is all highly speculative. So
But
But it,
Ron and George, were those kind of 1920s, 1950s, and people, were you looking at that work?
Certainly, I put it in my book, Charles
Yeah,
Brush. I'd forgotten him. Yes, that was
right,
interesting. Thanks, Rob. Yeah. So we did look at work like that.
right.
Um,
And
I- we did other things which were much more down to earth on gyroscopes. So from the history point of view,
right.
we talked to Lathwaite, of course, and we talked to Sandy Kidd, who claimed to have got an effect, and we tested that. As far as we could see, there is nothing in it. As George has said, it's like centrifugal force. There seems to be something to do with gravity there, but we
Yeah.
can't make use of it.
No, I can imagine that. Yeah, yeah, yeah. I mean, poor Eric Lathwaite, when he was made into such a, ignored by the physics community, because obviously centrifugal force has spinning things do have precession and a vector of movement, but it's not anti-gravity, is it? I mean, it's a very interesting effect. And, obviously later on, after he was branded, as anti-Newtonian, the centrifugal devices were used in low gravity and zero gravity in space research. I
Well,
mean, so, he was definitely onto something. Yeah.
yeah, I mean they do use gyroscopes in orbit now in
Right.
satellites for attitude control and
Attitude control.
potentially also for changing orbit. There's someone who used to work at Boeing called Mike Gamble
Mm,
who's done a few presentations in the past, and he said that they were able to apply certain what he called scissoring techniques to
oh,
gyroscopes, to where you have two sets and you swing them like that. In certain ways, it was able to adjust the orbital altitude. And I know that was it Robin Tucker at
it was,
Lancaster
yes, it
who
was.
look at ways of changing orbit using by basically changing the configuration of masses. So if you have two masses connected by a tether, you wind one in with the other, so you change the mass distribution in orbit. You could actually climb in orbit without pushing out any propellant. You could adjust your
right.
orbit. So there is that. There are small effects which could still be useful, even if we can't control gravity as such. We could use when you're in proximity to a large body like the Earth, you could using the gradient of its field by changing your position in that field, you can move. I know there was something recently, well, I say recently, a few years ago, called swimming in space-time,
Right.
where again it's saying if you're in a curved space-time, you can just by moving your mass around. If you have an extended mass, like
Yeah.
a body with different elements attached to it, by moving those around, you could actually move quite slowly, obviously, but you would move without propellant. So if you didn't mind waiting, you could actually get somewhere.
I think that is great. George, tell me about what you did. I mean, are you an engineer or a
Yes,
physicist?
yeah. Yeah, sort of aeronautical engineer, jack of
Right.
all trades. And
Ah, yeah.
yeah, my interest was more not so much in anti-gravity as propulsion in space without using fuel. And I think that's certainly Ron has covered quite a lot of that. And this is where you sort of think gyroscopes might or might not be producing useful forces. Maybe they're nothing like the mass of the body, which is what you need for getting into orbit.
Right.
But if you're out in space and you want to
Floaty,
keep
yeah.
on accelerating forever, then a small force without using fuel would be quite useful. So that's something that would be much more interesting to me as an engineer on flight performance and things like that, rather than anti-gravity, which may or may not be doable on this side of a black hole.
I know, but yeah, I can see the practical. So
Mm.
how was it's probably changed today from your day, but how was BAE set up? Where were the centers of excellence, and how did they split up stuff that they were working on?
Yeah, I think Ron can probably answer that better than I.
Okay,
Yeah.
where were you guys based for Greenglow?
Mostly at Walton.
Well, Plymouth was mainly to do with navigation, and gyroscopes play a big part in what's called inertial navigation, which is like a dead reckoning. So when you know where you start, and you know where
Right.
you know your initial position and attitude.
As you move.
So the attitude for attitude, you need the gyroscope, and so as you move along, your attitude changes, your position changes, and so on. So you combine gyroscopes and accelerometers, and they tell you essentially all your acceleration and all your rotation as you've moved, and you have to then integrate those back, and then you get position and you get velocity and position and attitude from it's basically looking at history. And so you want those to be very, very accurate, otherwise you get lost very quickly. So they specialize in things like laser gyroscopes, which are very, very accurate. So and Eric Lathwaite, apparently this is before my time, came down and gave a lecture to all the gyroscope experts there, and he was not well received at all.
Oh no.
So I think the problem, he was very well known, and was he had done a lot of successful work in maglev trains and things like that. So he knew his stuff, but I think when it came to gyroscopes, it was kind of outside of his experience. So he didn't have the same grounding, I think, in the mechanics of it that the engineers there had. So I think that was a lot of the problem. I think maybe Ron, you might be referring. Are you thinking of Roger Scheuer?
Yes, I am.
Because he worked for, I think, when it was Sperry gyroscope, before it was in Plymouth, maybe. Because it had started elsewhere in the country and had moved to Plymouth in the 80s. So I know he worked there at some point, but we never crossed paths there.
Right.
But yeah, Roger Scheuer is another, not gravity related, but a propulsion related thing.
Oh, I see. Right.
So
and was BAE one of the was laser gyroscopes a British invention, or?
I'm not sure. I don't think so. I think it came from Sagnac, who's French. But it was originally to try to find the speed of light. Experiments they would often set up interferometers to work out the speed of light. And I don't know if it was him or someone else who realized that this could be turned into a gyroscope, because as it turns, because the speed of light is constant, but if you turn the thing which it's reflecting within, then it reaches, and you have two beams which go in opposite directions, so they interfere. But when you rotate it, one of the beams has to go further than the other one does.
Right.
And so then the interference pattern changes, and you can then see very accurately how you've rotated. So that's the principle. But I think it was Sagnac who discovered it, but someone else may have realized that by rotating it,
I think it was Bob Ford's people at Hughes Aircraft, wasn't it?
Probably, yeah.
Hughes,
yeah.
Right. Okay, that's interesting.
And Sperry, obviously, the Sperry gyroscope had existed since the First World War, I think, with mechanical gyroscopes, and they obviously were quick to develop the laser ones as well.
Right, for accuracy. Yeah. Right, here's a real good off the wall question, which the obvious answer is no. Is there's possibly, if we have, and I think we do have, extraterrestrial intelligence out in the universe that might well have visited Earth, quite unlikely. They probably sent a probe, and to cross the vast distances of time and space, they probably know how to modify space-time and gravity, of course. If they ever crashed onto Earth, were you given a part of the crashed flying saucer to look at? George?
Not as far as I know, but it would be so secret. We wouldn't be told.
Right. You would just be handed, like, oh, I don't know what it is, but it's, yeah. What? How does it? Yeah, right. No, no.
Well, you're talking about carbon fiber there. I remember that. That did get passed around. Piece
Oh,
of carbon.
right. And of course, Ron and I have talked in an email about this. I'm particularly interested in metamaterials, and obviously Marconi, part of BAE, were big on radar metamaterials. So that must have been something that you were interested in. What was going on down the corridor?
Yeah, yeah, it was interesting. But that was at Bristol Selby Research Centre, and they were working with John Pendry from Imperial College.
Yes.
So,
As Rob's just said, now can possibly make a metamaterial which it can interact with visible light. Yeah.
well, it was interesting, particularly from the stealth point of view.
Yeah, definitely.
Mm.
And George, what do you know about metamaterials as aircraft coverings for stealth radar?
Very little indeed. I was much more interested in getting the shape right first.
Okay.
And when you got the shape right, you don't need to depend on your metamaterials anything like the same extent. So
Right.
I must admit I was on the practical side of shaping things rather than covering them. Yeah.
You don't want, yeah, if you got a good shape, you don't need to wrap it. Right.
That's basically, yes.
I have to. So a lot of people have been saying to me that something like the Avro Vulcan V bomber back in the 1950s was a very good stealthy shape.
Probably relative to some other shapes at the time, yes.
Right.
Yeah, I think that the mosquito was a famous example because I think mainly because it was wood.
Wood,
well.
yeah. Helps.
Yeah, yeah. But stealth's a whole different ball game from gravity or propulsion. So yeah.
It is. The other thing that's great about Mosquito, of course, it was glued together. I worked on a film about the man who invented epoxy resins at Cavendish in Cambridge. And if it wasn't for epoxy resins, he could never have glued the Mosquito together. I love stories like that. So Ron, what would you say? What was the final outcome of Greenglow, and how was it presented to your bosses, and how did it go down, and what did they do with it?
Well, they funded it for 5 or 6 years, George, was it? I think
Must have been that, yes. Yeah.
Right.
If I was we had a meeting with NASA. They came to our site, so some of our big bosses attended the meeting with a lot of professors. Were you there, Rob? Did you come?
Not to that one, no.
Yeah.
That was with Mark Millis from
Yeah.
the
Yes, Mark
Quantum
Millis.
Physics program.
Yeah.
I didn't get to meet him. No.
So that's, I mean, his own work is still ongoing, isn't it? But NASA stopped funding him now.
Yeah. Yeah, I think there is it Eagle Works, it's called, I think it's in Houston. There's a guy called Sonny White who runs it. I think it's a sort of a kind of informal NASA program. But he's the only active person I can think of at NASA at the moment.
So did British Air BAE carry on looking at gravity masking, augmentation, or whatever you want to call it, after you guys finished your report, or did it come to an end?
Came to an end.
Right. Why aren't they working on it today? Or are they? They could be, I suppose.
It could be. I mean, we wouldn't know now.
You wouldn't know now, right? Right.
Yeah, I seem to remember. Oh, carry on.
I was just going to say to any of you, what do you think was the most the best hint that something could work that you came across? What would be the approach that you think would be the most positive?
I'm out on a limb because I can't see any way with our present knowledge of making use of Einstein's gravitational theory. I just can't see it.
Mhm.
That's not to say it's not there. We just haven't spotted it. But I've got another idea, which is, as Rob knows, I've been looking at thermodynamics for several years now.
Okay.
And a lot of other scientists have looked at the link between thermodynamics and gravity. I've got my own way of looking at it. And I'm still pressing on with that. I could be totally wrong. Who knows? I might just be in the right area. But
Fantastic.
no money.
Oh, right.
See, as well as having an idea, someone has got to do the experiment. You must find an experimentalist. My experimentalist is sitting in the corner there, George.
Hey, George. Yeah, you are. George, if you
Yeah.
come across this company called Vulcan Space, I mean, I think, I should point everybody in their direction because they are doing practical experiments. One of the things, I'm such a scatterbrain, but Ron, what you just said is very interesting because one of the things that this Vulcan Space experimentalist, George, people are doing
Yeah.
is that they've discovered that gravity masking, or what you want to call it, shielding, tends to go down in quantum steps, and you can almost absorb the energy out of matter to make it become more and more and more shielded, maybe from the effects of gravity. So maybe Ron, you're onto something, that there's that there is almost like an energy which needs to be modified to have an effect. Do you know anything about what they're doing with that? Or is that, does that kind of ring any bells with what you're saying?
No, I watched the YouTube that you
Yeah,
sent me the other day. I found that interesting, but it's not an area that I've worked on. I mean, I certainly looked at it because I thought it was very
yeah.
interesting to begin with.
Mhm.
Whether there's anything in it or not, I don't know. It does need, like the Vulcan team are doing, they're doing an experiment and exploring.
Right,
That's what you've got to do. It's all very well having an idea. I've
right,
got an idea, but I'm not going anywhere with it.
right, right.
Yeah, this is something funding has always been an issue, and I think now it's almost going back to the way it was in the 19th century and before, where you have to find a patron to actually finance things because big business doesn't see an immediate return, so they're not really interested. The blue sky research is not really a thing, as far as I'm aware. It seems to have dropped away. So either Falcon Space are privately financed. I think most of the other labs that I know of also are privately financed. So
The academic world is very anti looking at unusual things, isn't it? And academics are very,
anti-gravity.
yeah, that's right. You become another Lathwaite if you're not careful.
Right,
So
very easy to fall into that trap, and it seems like
mm,
big science right now. It seems to carry on, just carrying on their old
super
experiments.
CERN, yes,
Yeah, it's a classic example. I mean, I think CERN does amazing work,
yeah,
but yeah, to be a real maverick in research is almost impossible. And you were very
yeah,
lucky to have bosses at British BAE who were
yeah.
prepared to let you guys look into this. So it was an amazing time. What years did your project run, Ron?
Well, it started off probably 1990, 1989,
Okay.
1990,
Right.
with the technical director showing some interest.
Mhm.
He was interviewed by Nick Cook, who you know.
Yeah.
So, and then we explored that side a bit more.
Yeah.
We then heard about Podkletnov and various things like that all came together at that time. NASA were doing its own program, but by 2005, we'd stopped.
Okay.
We hadn't, I mean, we worked with Robin Tucker, who's a gravitational physicist. He's still
Right.
around as far as I know, but that's academia, and the academics have not come up with anything. The industry will say, yes, we want some of that, please.
Mm.
Yeah, yeah, yeah. When I spoke to Frederick Alphonson's son, David, and he said when his dad was approached by the Air Force with who he thought were just interested in his theory, they said, and George, you'd relate to this, they said, when can you build us the aeroplane? Where he went, well, I'm still working on the theory, mate. And so he realized that they just wanted to immediately go to a platform rather than, to talk about it. Have you come across that with theories and they just say, when is it going to fly?
It's a natural reaction from the Air Force and people. Might have to go to war tomorrow, and they're not really interested in 50-year research programs.
Right.
Actually, you've sort of mentioned something that was of interest to us, in that UK intelligence was interested in what we were doing.
Oh, right.
Because they wanted to know what the enemy was doing. And if we were working on a particular area, perhaps they were too. So that was of interest. Didn't bring any money in, but
yeah.
Everybody thinks that maybe another country, a foreign power, has got a lead on this gravity research. So it's important to. But did British intelligence share with you guys anything that they thought was going on in a foreign country?
No, it's always one way.
Okay.
Always one way.
They were not helpful.
Well, they might have been helpful, but not in telling us, we know what the other side are doing. They don't.
Right.
But I mean, since we are talking about intelligence, I mean, Russia has got some marvelous mathematicians and physicists. It's quite likely they're working on something.
Right.
But we haven't heard.
Right.
We haven't heard. And we're more likely to hear from the Americans. But I mean, their levels of secrecy are enormous. So you've probably heard of Bob Lazar. Tell me you've heard of Bob Lazar.
Yeah, of course.
At Area 51. Now, perhaps we could ask, what do you make of him?
Yeah.
What
I think is more, I mean, Bob is a very interesting character, and he obviously did some work at, but what he was doing is working for the American defense contractors. And I worry that Raytheon, Lockheed Martin, or whoever are they going to be the very last people who want to share anything that they're working on with, publicly or with their rivals. I mean, wasn't BAE a bit like that? Weren't you working for a giant international defense contractor who wanted to keep everything secret?
The answer is yes. In fact, the director would say, "We've spent the money. We're not giving anybody else any information."
Right.
So we had to be careful. We've been probably sacked if we had done. But fortunately for me, I never had anything.
Right. And did you get the impression that other defense contractors were working on the similar? You said NASA, but wasn't there a Boeing program?
Yes, there was.
Probably Lockheed Martin. Yeah.
Childress was his name, I think. Was it Jamie Childress?
Yes.
Him and his brother, wasn't it? Yeah.
Yes, his brother is David Childress, who's
that's right.
Again, sort of notorious in the.
Yeah.
Right.
Oh yeah, certainly Boeing were interested.
Yes. Yeah.
Which no doubt they should be. So, George, what have you come across anything as an aerospace engineer that could? We were talking earlier about maybe tiny but small percentages of lift augmentation. Have you come across anything, plasma laminar flow techniques that could augment lift or reduce?
Well, augmenting lift is you've got to augment it a lot to be of any use, really.
Okay.
Whereas with propulsion, a small change can be very useful. So I was always more interested in the propulsion side of things.
We did do a test in the wind tunnel, George. Do you remember? with the plasma on a wing.
Yes, yeah. Well,
yeah.
again, we were trying to reduce drag, I think, at the time. But I don't think we produced any effects worth writing home about at the time. But
not at the time. No, we had a very smooth plasma, wasn't it?
oh, it was. Yeah, that's right.
Smooth, yeah.
Well, of course, plasma were also interested for stealth, weren't they? So
of course, yes.
And but again, it's not clear whether they're being used for that or whether it's just good shape and metamaterials are doing the job well enough.
Yeah.
Yeah.
But George, as you say, when you're in space, when you're out of in zero gravity, and you've got a small force that can accelerate, you can do a lot.
Well, this is always why there was the interest in gyroscopes, because you can always power a gyroscope with solar cells and sort of keep it going for years, and you know, possibly even get out of the solar system. But again, it's not clear that any of the gyroscopes produced forces that were measurable or useful. And this is perhaps where it's a shame that Lathwaite's and his ilk didn't manage to produce something. But if you say there are people with scissoring twin gyroscopes, maybe they are getting effects that could be useful. I'd like to read up on that.
Yeah, I think Falcon Space are looking into that. They've been working with Mike Gamble. I don't know if they've come up with anything, whether the experiments worked or not. But they're looking into many different aspects. I think them other companies as well. The major thrust at the moment is more into electrical systems, so electrostatic or electrokinetic, for providing some kind of long-term propulsion. Obviously, at the moment there's ion propulsion, but they're also looking at potentially other methods that don't involve propellant, or at least don't involve propellant that you carry with you. So, for example, there's a lot of interest in what they call very low Earth orbit now, so 100 kilometers, 150 kilometers, where there is some atmosphere to work with. So obviously it's dragging you down, but if you could then potentially maybe accelerate some of it and make use of it, you could sustain your very low orbit. So that's another area that they're looking into.
Yeah, I mean, this is where Scheuer's EM drive looked interesting, but again, it doesn't seem to be repeatable, producing anything of any interest.
Yeah,
I don't know whether we tried contacting him and offered to come and debug his apparatus for him, but he was flying at the time, so he didn't really want to be dragged down.
Oh, right.
Because apparently China is very interested, according to Roger anyway, that there's some work on it going on in China. So again, we don't know if that's successful or not, and I'm sure they wouldn't tell us. So
the Chinese are a big country, and they can afford to be interested in an awful lot of things. And I've seen some of the on sort of aeronautical projects, they're pursuing things that everyone else gave up years ago. So the fact that somebody in China is looking at it doesn't necessarily mean it's going anywhere, but good luck to them.
And there are a couple of other companies in the US, as IVO, and also Exodus Propulsion. I don't know if that rings a bell with anyone. They are looking into similar electrostatic, potentially, methods of propulsion. I think IVO had put one on a satellite, which went up earlier this week, or last week, rather. So we may soon have some idea whether that works or not. Because that's an electrostatic method, which was patented about 30 years ago by a Frenchman called Laforgue. So you'll see references to the Laforgue thruster on the internet and various places, which may or may not be the same thing that Townsend Brown saw in the Biefeld-Brown effect. So again, it's kind of, there's so much legendary status around that. It's very difficult to determine truth from fiction when it comes to that. But they are at least at the moment, they are putting up satellites and doing some experiments in space to see if there is anything to it.
That's what Ron says. You've got to do some experiments, and unfortunately, the answer might be no when you've done it.
Sure, absolutely. So the Tasman Brown effect from the 1950s. What did you guys look into that? I mean, does it work?
Townsend Brown. I presume there's something there, but
right.
We didn't follow it up.
No, there were some. I think there were some individual research projects. There was something at BAE called the Lookout program, and there were one or two people who did sort of very small studies. It was sort of like an internship kind of study, and there was at least one that I knew of who contacted me for more information, and that was essentially, it was the ion wind effect was what they came, which was what you saw in the lifters around the end of the 90s, early 2000s. People like Tim Ventura were experimenting with what's called lifters, which was a kind of very simplified apparatus, which seemed to be working just by ion wind. So it would cause a wind from being drawn or repelled from electric charges, and so that would force it upwards. There may be more to it than that, though. I know Tim would say that they always felt that there was something else going on that wasn't just the ion wind.
Right.
So maybe there is some other effect going on.
What do you think, George? Ionic propulsion? Well, in our atmosphere?
I've seen these lifters, and again, they produce very small effects, which are no good for anti-gravity, but again, might be useful. But do they depend on having air to create the ion wind? That's the problem. So there'd be no use in space either.
They won't work in space. No.
Yeah.
So have you guys kept in touch with Sandy Kidd? Do you know what Sandy's up to? Did you tested his machine, but do you know what he's doing more today? Didn't he carry on to modify another machine?
I think he did, but I've not. I get a Christmas card from him, but I've not kept up in touch with him.
Right.
Yeah, he's given presentations at APEC,
he has, hasn't he? Yes.
Conference. That was a couple of years ago. So he is still active in the field, but obviously getting on in years now.
Aren't we all?
Yeah, we're all getting on a bit. Well, thank you. Yeah,
I want something now, please. Aren't you going to give us something?
Yeah, please. No, I'm going to give you a great thanks for chatting me for all of us today, and so. Do you think in our lifetimes we're all, apart from Rob, we're all getting on a bit? Are we going to be seeing anti-gravity flying saucers taking off from a secret base in Nevada?
You can never tell with the breakthrough. It just comes, and then you've got to rush with it because everybody else will want it.
Right.
So have a look at thermodynamics. I gave a presentation to APEC.
Great.
Have a look on, there are things wrong with it. I've been doing it again, and various people have been correcting me. But I still think, for me, it gives me something to think about. Nobody else seems to bother with it. So maybe there's nothing there. But what else is there to look at? I cannot see general relativity
you said
giving us an answer. I just cannot see it.
Yeah. Oh, I've always wanted to ask you something, Ron. You, in a small clip, I don't think it was from the BBC Horizon program, but correct me if I'm wrong, you went to see the chief of Porton Down, where you were invited to Porton Down, and he took you into a facility where he showed you a machine that they'd been working on.
Yes.
That was the end of it. They didn't really say what it did, and maybe you couldn't or he couldn't talk about it. What were they up to?
They were using, what would they call it? It's got a name, hasn't it?
Is it a squid? Superconducting quantum something?
Probably, but what do they call it when they have all these particles? What's the name for that? It's got a name.
Well, it was like Brownian motion, wasn't it? That
Yes,
they
yeah,
were
that's not.
in a cloud chamber. That it
Was it?
looked like that's what you were looking at.
That's what it's like. It's like a cloud chamber. It's got a name. Other
Right,
people are working on it, and they could
right,
detect things. I mean, why I was interested in it from the stealth point of view. At the moment, they can detect masses in terms of meters away, but we're interested in terms of kilometers away. Kilometers away.
of course.
But we're not there yet. But nevertheless, it's very, very interesting.
So it wasn't ever a gravity research or anti-gravity research. It was a detection mechanism.
Yes. Yes.
Okay, all right, fantastic.
It was
Well,
gravity,
gentlemen,
of course.
thank you
Yeah.
very much
Yeah.
for today. And we should all keep in touch with what people, experimenters like Vulcan Space and other people are doing. So
Yeah.
maybe there is something around the corner, or maybe there already is something here.
Yeah, I know the Falcon Space people as well. They've been very keen on this sort of Manhattan Project 2.0. So
Yes.
there is a definite, need, if not a desire, on behalf of everyone really in the community. It's a very small community, so yeah.
Yeah, we have to. I mean, however good we are at building bigger SpaceX rockets, we have to get away from using propulsion.
Absolutely.
Yeah.
And we need to modify space-time.
I think that'll be hard.
Keep in touch. Thank you. Bye.
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 That was great. I certainly will keep in touch, gentlemen, and I will keep in touch for you viewers, because I think in 2025 we are actually on a cusp of discovering anti-gravity, gravity masking, gravity modification. Thank you very much for watching. If you got right to the end part here, please give this film a big thumbs up and subscribe for more, because the truth is out there.